Today we are going to learn about applied optimization with regards to derivatives, and then we start to learn about antiderivatives, or you will know later by the name integral, and we will also learn about the sigma notation and definite integral and the fundamental theorem of calculus for this morning session. Yeah. So for the first part, we will learn about applied optimization, which is actually just some examples related to calculus, which we will apply our theory about differentiation for applied for optimization problems. So how to solve an optimization problem? These are the step by step that you need to make sure you understand. The first step is you have to make sure that you read the problem properly. You have to understand the problem completely. And then you ask what is given in the problem, what is the unknown to be optimized, and so on and so forth. And then the second step is for you to draw a picture. Well, this is not necessarily important, but most of the time, drawing a picture helps you to solve the problem better. And make sure if you draw the picture, you put all the label on the picture. And then we go to the third step, which is we introduce the variables that we need in this optimization problem. And while we are writing the variables, we have to list also all relations, every relations between variables and parameters in the picture. And after that, we write the equation for the unknown quantity. Number 4 is basically we want to write the equation that relates us with the output that we want to have. And then after that, we test the critical points, endpoints, and put everything there to get the optimal value. This is the first example. We have an open top box, which can be made by cutting small congruent squares from corners of this 12-inch by 12-inch squares. The question is, how large should we cut the corners such that the volume of the box, so such that the box can hold as much as possible. So basically it says that the volume of the box is maximized. Jadi di contoh ini ya, kita punya box yang terbuka, di atasnya tidak ada tutupnya, hanya ada dinding samping dan alasnya saja. Nah, itu bisa dibuat dengan memotong 4 ujungnya dengan ukuran yang sama, dan potongannya harus berbentuk persegi. Pertanyaannya adalah sebesar apa kita harus memotong bagian ujungnya ini ya, semua bagian ujungnya ini di masing-masingnya, supaya volume yang kita supaya box kita nanti setelah kita buat, kita bisa menampung sebanyak-banyaknya, alias volumenya semakin besar. So first we read the problem ya. As soon as we understand the problem, we draw the picture. So we have the box like the bottom picture, and this is the top picture is the construction of the box. Jadi kita sudah paham masalahnya, kemudian kita menggambar, kemudian kita taruh semua variabelnya dan parameter yang ada. And then since we want to question what is the largest volume of the box, largest possible volume of the box. What we have is we compute the volume in this way. Yeah, the volume is the area of base and multiplied by the height. Volumenya adalah luas dari alas kali tinggi. Ya. The area of the height is 12 minus 2x. Why? Because we have the paper dimension is 12 inch by 12 inch. So if we cut both corners, meaning that we cut 2 times x on each side. On all side. Di sini kita punya sisinya adalah 12 min 2x ya. Because when we make the box, then we only have 12 minus 2x as the base dimension, and then we have the height to be x. You see here that with the bottom picture we can easily see what are the variables in this problem. Jadi kita tahu variabel apa saja di problem ini berdasarkan gambar ini. Then from here we know that x is only between 0 to 6. Kita tahu bahwa x itu cuma bisa dari 0 sampai 6. Why? Because we only have 12 inch long. Karena kita cuma punya 12 inci. Then if we take from the right by x and from the left by x, then we can only have x can only be 6. Di x-nya cuma bisa 6 maksimal. Then here we want to find x that maximizes volume of the box. How? So we have the volume here, x times side square, so x times 12 minus 2x squared. Then we find the first derivative of the volume with respect to x. And we have that the derivative of the volume with respect to x is 144 minus 96x plus 12x squared, which is equal to 12 times 2 minus x times 6 minus x. Di sini kita punya untuk mencari nilai optimalnya, maka kita mencari turunan pertamanya terhadap x. Kita dapat turunan pertamanya adalah 12 kali 2 min x kali 6 min x. So here we have that the critical point is 2, and the endpoints are 0 and 6. The endpoint comes from this fact. Jadi di sini kita punya titik kritisnya adalah 2 dan titik ujungnya adalah 0 dan 6 ya, karena x-nya hanya bisa dari 0 sampai 6 saja. Then we compute the value at critical points and the endpoints. We have that at the critical points V2 is equal to 128 inch cube. And at the endpoints, the volume is 0. Jadi kita punya di titik kritis volumenya adalah 128, di titik ujung volumenya adalah 0. Then in this case we have that the maximum value of the volume is 128 inch cube. With the square should be, we should cut only 2 inch on a side. Jadi volume maksimumnya adalah 128 inci pangkat 3, di mana kita bisa mendapatkan itu dengan hanya memotong 2 inci di masing-masing sisi. For this example, any question?
Sir.
Ya?
Itu endpoint-nya ada 2 berarti ya?
Yes. The endpoints come from this fact. Because x can only can only be from 0 to 6. That's why.
Okay. I get it. Thank you, sir.
Any more question?
If kalau X-nya tuh jadi 1, tapi si X yang satu lagi 6, nggak apa-apa itu, sir? Atau harus 0 sama 6?
It can only be 0 and 6 because the endpoints are 0 and 6. Titik ujungnya hanya 0 dan 6. Karena apa? Karena kita hanya bisa tidak memotong sama sekali ujungnya, atau kita memotong 6 inci. Ya. Did you get it?
Get it, sir. I get it.
Yeah. Any other question? No? Then let's go to the next example. So here in this example, let's say you are now a designer in an industry that makes cylinder can. Ya, misalkan kalian sekarang adalah pekerja atau designer dari di perusahaan yang membuat kaleng berbentuk silinder. Then here you are asked to design a 1 liter can. Jadi kalian diminta untuk mendesain kaleng yang berbentuk silinder dengan volumenya 1 liter. Dan the question is what dimension will use the least material, ya. Pertanyaannya adalah dimensi seperti apa supaya kita bisa mendapatkan 1 liter silinder berukuran 1 liter, tapi material yang dipakai paling sedikit. Then how to do it? We draw the cylinder, which in this case we have that the dimension is 2r, and the height is h. Then in this case, the volume is pi r squared h. The volume is the area of the base times h. So we have pi r squared times h. And since we only design a 1 liter can, then it must be equal to 1000. Why? Because the radius and the height are measured in centimeters. Ya. Jadi di sini karena kita mau membuat silinder, kaleng silinder yang berukuran berkapasitas 1 liter. Ya, 1 liter adalah 1000 cm kubik. Maka kita punya volumenya sama dengan 1000, ya. This is the volume of the cylinder. Kita tahu bahwa volume dari silinder atau tabung ini adalah pi r kuadrat luas alas kali tinggi, ya, pi r kuadrat h. We have that the volume is pi r square h equal to 1000. And then the question is actually the dimension that will use the least material, ya. Pertanyaannya adalah dimensi seperti apa yang menggunakan material paling sedikit. The material is only the surface area, ya. Materialnya itu hanya dipakai untuk membangun selimutnya, dinding, the wall and the cap, dinding dan tutupnya atas bawah. So we have that the surface area is the area 2 times the area of the circle, 2 kali area lingkaran, 2 kali luas lingkaran, plus wait. So here we have that. Sorry, there was a distraction. So here we have that the area, the surface area, is 2 times the area of the circle, plus the area of the wall. So we have 2 pi r squared, which in this case the area of the circle is pi r squared. We multiply by 2 because we have the bottom circle and the top circle. And then we have the cylindrical wall, which can be measured, which can be computed, which the area can be computed by 2 pi rh. Then in this case, we have that, okay, pi rh is 1000 over r. So in this case, we have that 2 pi rh is actually equal to 2000 over r. Jadi karena kita punya volumenya ya, pi r kuadrat h adalah 1000 per adalah 1000, maka pi rh adalah 1000 per r ya. Maka 2 kali pi rh adalah 2000 per r. Dan of course in this case the natural domain of A must be r positif ya. Jadi natural domainnya adalah r-nya harus positif, radiusnya harus positif. Then after this we find the first derivative of A with respect to r, which is 4 pi r minus 2000 over r squared ya, from here. 4 pi r minus 2000 over r squared. Then the critical point is only r about square root of 3 of 500 over pi, because we want to make this guy to be equal to 0. So the critical point is around 5.42. Then next, since we want to find minimum, yeah, we can find the second derivative, which is actually 4 pi. This should be 4000 r power 3. Sorry. Yeah, this should be r power 3. This is my mistake. Let me change it. So we have r power 3 now. So 4000 over r power 3. Then in this case, we have that the value is always positive throughout the domain of A, because r is always positive. Because here we have that r is more than 0. Then in this case, we have, since the second derivative is always positive, we have that this critical points r equals to root of 3 of 500 over pi is actually the absolute minimum. So therefore, we have that the radius must be around 5.42 with the height around 10.48. Jadi di sini kita dapat bahwa dengan turunan pertama kita mendapatkan titik kritisnya ya, R akar pangkat 3 dari 500 per pi. Kemudian dari turunan kedua kita bisa memeriksa bahwa untuk R positif, di sini turunan keduanya selalu positif, maka kita punya R yang tadi titik kritis ini adalah nilai absolut minimum. Maka dimensi yang membuat 1 liter tabung dengan bahan paling sedikit adalah R-nya 5,42 dan hanya 10,48. Any question for this example? Is it clear?
Sir, just want to make sure. Jadi the critical point of R, it becomes the absolute minimum.
Yeah, in this case, yes.
So we don't use absolute maximum.
No, there is no absolute maximum.
Okay. Okay.
Yeah, in here there is no absolute maximum because the second derivative is always positive in the domain of R. Karena turunan keduanya selalu positif, maka kita tidak akan punya absolute maksimum ya. Kalian silahkan baca di slide minggu lalu. Di situ ada yang aturan turunan kedua. Any more question? No?
I think no, sir.
If not, then this is the last two examples. So in this case, we have that, okay, we want to draw a rectangle inside a semicircle of radius 2. The question is, what is the largest area the rectangle can have, and what are its dimensions? Jadi di sini kita mau menggambar persegi panjang di dalam sebuah lingkaran dengan jari-jari 2. Pertanyaannya adalah luas terbesar yang mungkin dari persegi panjangnya berapa dan dimensinya berapa. So in this case, we have that the equation of the rectangle, the equation of the semicircle is x squared plus y squared equal to 4. Kita punya bahwa persamaan lingkarannya karena di sini semicircle ya, kita ambil hanya x, y-nya adalah akar dari 4x min 2 ya. Because this is only semicircle, we take the top one, and in this case we only have y equals to square root of 4 minus x squared. Then in this case we have that the length of the rectangle is 2 times x, and the height is square root of 4 minus x squared, which gives us the area 2x times square root of 4 minus x squared ya. Jadi di sini kita punya panjang dari persegi panjangnya adalah 2x. Kemudian tingginya adalah akar dari 4 min x kuadrat. Sehingga luasnya adalah 2x kali akar 4 min x kuadrat. From the figure, we have that x is actually from x is actually from 0 to 2, not from minus 2 to 2. Jadi di sini dari gambar sebenarnya kita dapat bahwa x-nya adalah dari 0 sampai 2 ya, kita bukan dari min 2 sampai 2. Karena kita cukup menghitung yang karena kita pakai panjangnya adalah 2x, jadi kita cukup menghitung yang bagian kanannya sumbu y saja. So our goal here is to find x between 0 to 2 that minimize the area. So we find the first derivative, and then we know here that the first derivative is undefined if x is equal to 2 ya. Dia tidak terdefinisi ketika x-nya adalah 2. And is 0 if x is plus minus square root of 2. Dan dia 0, turunan pertamanya 0 ketika x-nya adalah plus minus akar 2. Since we want to find between 0 to 2, then we only take the plus sign. Ya. Jadi karena kita mau mencari x antara 0 sampai 2, kita cuma butuh x yang positif saja, yang positif akar 2. Then we found that the critical point value is a of square root of 2 is 4, and at the end points the area are 0. Jadi kemudian kita masukkan di titik kritisnya luasnya adalah 4, di titik ujungnya masing-masing luasnya adalah 0. So in this case we have that the area has a maximum value of 4 when the rectangle is square root of 2 units high and 2 times square root of 2 units long. Jadi kita masukkan x-nya yang plus akar 2 ini, sehingga kita dapatkan tingginya adalah plus akar 2. panjangnya adalah 2 kali akar 2. Any question for this example? Is it clear? Clear enough?
Sir.
Ya.
Tadi kan yang sebelumnya endpoint-nya itu 0 to 6, but why in this example the A is 0 with 0 again, not with 6?
Here.
Yeah.
So X is from 0 to 2 in this case. So, okay. Let me explain it in bahasa. Ya. X di sini hanya dari 0 sampai 2 karena perseginya ada di dalam setengah lingkaran yang berjari-jari 2. Jadi X-nya tidak mungkin lebih dari 2. You see here that the X is from 0 to here, to a point X. Then in this case, X can only be from 0 to 2 because the radius of the semicircle is only 2.
Okay. I just noticed that the 0 is less than X less than 2. I'm sorry, sir. My negligence.
Any other question?
I think not for now, sir.
No. Then this is the last example. Yeah. Suppose that we have R of X is 9X and C of X is X cubed minus 6X squared plus 15X, where X represent millions of MP3 players produced. The question is there a production level that maximizes profit? If so, what is it? Jadi di sini kita punya R adalah R adalah revenue, dan we have that R is the revenue and C is I think the capacity. Jadi di sini kita punya R-nya revenue dan C adalah kapasitas produksi. Ya. And then in this case, X represent millions of MP3 players produced. Jadi di sini X adalah banyaknya dalam juta ya, MP3 player yang dibuat. The question is there a production level that maximize profit? Ya, di sini kita mencari apakah bisa kita memaksimumkan profit. If so, what is it? Then in this case we have that R prime and C prime. Ya, kita punya turunan pertamanya, which are easy to get. Then to get the production level that maximize profit, in this case we have to make R prime to be equal to C prime. That is 9 equals 3x squared minus 12x plus 5 ya. Kenapa di sini kita punya R aksen sama dengan si aksen? Karena mereka saling berhubungan. Then in this case we find that if R prime equal to C prime, we have that x squared minus 4x plus 2 equal to 0. Then we use the ABC rules to get 2 minus square root of 2 and 2 plus square root of 2, which are the x's. Then to find the maximum profit, we find the second derivative of R prime and C prime. R prime equals C prime. Then in this case we found that the second derivative is only the second derivative of C prime. In this case we have that the second derivative, sorry, it should be minus C prime. Here another mistake in the slides. Minus C double prime. So, in this case, the value is negative at x1 and positive at x2. Yeah. because the second derivative is negative at x1 and positive at x2, we have that the minimum is at x1 and the maximum is at x. The second derivative is 6x minus 12. Six x minus 12 is okay. Yeah. This is negative at x1 because we have 2 minus 2. Yes, negative, and positive at x2. Therefore, we have the maximum profit, okay, obtained at x2. Yeah, that's correct. Now let's go to the challenge. I will go a little bit quick in this challenge. Yeah. What is the smallest perimeter of possible of a rectangle whose area is 16 inch square? So in this case, what we want to find, okay, we have a rectangle. We have a rectangle. Let's say this is x, this is y. Yeah, and area is x times y, which is equal to 16. And the question is the perimeter. Yeah, the perimeter is 2 times x plus y. From the area, we found that y is equal to 16 over x. So we have that the perimeter is now 2 times x plus 16 over x, which in this case we have 2x plus 32 over x. To find the optimization, to solve it, we find the first derivative, which is equal to 2 minus 16 over x squared. 2 minus 16 over x squared. Yeah, by the way, here in this case, x must be greater or equal to 0 and y is greater or equal to 0. So this is not 16. 2 minus 32x over x squared. We make it equal to 0. Then in this case, we have that x squared is equal to 32 over 2, which is equal to 16. Then in this case, we have that x is plus minus 4, but we only take x equal to 4. Then the smallest perimeter possible is p equal to 2 times x plus 16 over x, which is 2 times 4 plus 4, which is 16. Any question? No? That's clear. Okay. Now the second problem. A rectangle has its base on x-axis and its upper two vertices on the parabola. Wait a moment, okay? Now the question is, we have what is the largest area the rectangle can have, and what are its dimensions. So here we have the rectangle has its base on the x-axis and its upper two vertices on the parabola. So basically what we do here, what we need to do, we draw the parabola. So we draw the parabola like this. There's x and y, and we have the parabola like this. Maybe this is okay. This is 12. Sorry, this is a very bad picture. Let me make it better. Let's say this is the perfect parabola. This is obviously not, but okay. And we want to make the rectangle. Yeah, the rectangle is somewhere here inside. So we have here x. The length of this guy is also x, and the height is actually 12 minus x squared. In this case, the area is 2x times 12 minus x squared. Or we can write it to be 24x minus 2x power 3. Yeah. So what the question is, what is the largest area the rectangle can have? In this case, okay, from here we know that x is from 0 to when y is equal to 0, x is square root of 12, or 2 square root of 3. So in this case, we find the first derivative a prime, which is 24 minus 6x squared, which is equal to 6 times 2 minus x times 2 plus x. So we have x equal to 2 or x equal to minus 2, which is not possible because x must be positive. So in this case, we find that a at 2 is equal to 24 times 2 minus 2 times x 2 times 2 cube, which is equal to 24 minus 8. 24 minus 8 is 16 times 2, 32. This is the largest area, because obviously in this case a 0 equal to a at 2 square root of 3, which is 0. So here is the maximum, 32, with the dimension x equal to 2 and y equals to 12 minus 2 squared, which is 12 minus 4, which is 8. Is it clear for this one?
Sir.
Ya.
Itu yang sebelum 32 yang kotakin itu dalam kurung apa ya, sir?
2.
Oh, so 2 dalam kurung 2 pangkat 3 ya, sir?
Ya, like this.
Ya, oke.
Okay. Now the next one. So in this case, we are asked to have a rectangular plot of farmland will be bounded by one side, on one side by a river, other three side by a single strand electric fence with 800 meters of wire at your disposal. Rectangular. So to draw it, let's say we have here the river. Here is the river, and the farmland is this rectangular area. So the farmland is this guy. And we have, let's say, here is x, and the height is y. Then in this case, area is equal to x times y. And since we only bound the farmland on three other sides, so in this case we have that the total the wire. So it must be, let's say the wire must be 2x plus y, which must be less than or equal to 800. Or in this case, let's say that we use all the wire. Yeah. Then in this case, we make it equal to 800. So we have that y is equal to 800 minus 2x, which means that the area is now x times 800 minus 2x, which is equal to 800x minus 2x squared. So in this case, again, we find the critical points. Yeah, a prime is equal to 800 minus 4x, which makes us this is equal to 0. So in this case, x is equal to 800 over 4, which is 200. So the area is now here x can only be from 0 to 800. So the area at 200 is actually 200 times 800 minus 2 times 200.
One money for that car,
which is 200 times times 400, which is equal to 80,000 meter square.
For that car, can you have one money for that?
Sorry, there was a distraction. Yeah. For this example, is it clear? This is still easy, right?
So I can follow.
Ini kancing.
Now we find try to solve the last problem. Yeah. We are to construct an open rectangular box with a square base and a volume of 48 feet square.
I have one money for a mop. I have one. I have
So here we can draw a rectangular box with the base, with a square base, and we have so here is the construction. And we know that, okay, let's say this is x, yeah, and the height is y. Then we have that the volume is actually x squared y, which is here equal to 48. So we have that y is equal to 48 over x squared. The material for the bottom costs $6 per feet square, and for the sides costs $4 per feet squares. What dimensions will result in the least expensive box? So we have that the total area. I mean, okay. The cost C is equal to 6 times the area of the square bottom, yeah, 6 times x squared plus 4 times 4 times 4 times x times y, which is 6x squared plus 16xy. And in this case, we have that 6x squared plus 16 plus 48. 16 times 48. 16 times 48 over x. So in this case, we have that C prime is 12x minus what is 16 times 48? Let me use calculator. It's 768. 768 over x squared. If we want to make it equal to 0, then we have that x cubed is equal to 768 over 12, which is equal to 64. So in this case, we have that x is equal to x is equal to what? What is the root of root 3 of 64? 64 4. Yes, 4, because 4 power 3 is 64. Then in this case, we have that the dimension. Okay, sorry. Let's check. Yeah. C at 4 is actually 6 times 16 plus 4 times 16 times 48 over 4. Yeah. So in this case, we have that 6 times 16 is 96, and 48 times 4 is 192. So we have that the cost is actually $288. With the dimension x equal to 4 and y equal to 48 over 16 is 3. Any question? Okay. To see if this is a minimum, you can actually find the second derivative, because we have that x must be greater or equal to 0 and y is greater or equal to 0. Then in this case, we have that c double prime is actually 12 plus 768 divided by 2 is 384 over x cubed, yeah, x cubed, which is always greater than 0. So we have a minimum here. Yeah. Any question? No?
I think no, sir.
If not that, then let's go to antiderivative. What is antiderivatives? Antiderivative is basically, well, you will understand it, you will know it later by the name of integral. So antiderivative, so if we have a function f, capital F is antiderivative of small f if the derivative of capital F is small f. Jadi apa itu anti turunan? Ya, anti turunan f adalah anti turunan f kapital, ya, f besar adalah anti turunan dari f kecil kalau f besar diturunkan terhadap x adalah f kecil. So these are the examples. Ya. The antiderivative of 2x is x squared. Why? Because if we take the derivative of x squared with respect to x is 2x. The antiderivative of cosine x is sine x. Why? Because the derivative of sine x is cosine x. And the antiderivative of 1 over x plus 2 times e power 2x is actually ln absolute x plus e power 2x. Why? Because if we differentiate it, we go back to small h. Yeah. For this example, any question? No? Yeah, so basically the idea is we think backward. Yeah. We want to find a function that we know that the derivative is equal to the given function. Ya. Jadi di sini kita berpikirnya kebalik, ya. Kita mau mencari fungsi yang kita tahu turunannya adalah fungsi yang kita cari, fungsi yang kita punya. And in general, the antiderivative is in this form. Ya. In general, the you will have an additional constant. Ya. pada umumnya kalian akan punya tambahan konstanta. This is the most general antiderivative of f. So, for example, okay, if we want to find an antiderivative of f of x equal to 3x squared, yeah. So, we want to find the antiderivative of 3x squared that satisfies capital F1 equals to -1. Di sini kita mau mencari antiturunan dari 3x kuadrat, di mana nilai dari antiturunannya di titik x sama dengan 1 adalah -1. So, since we know that the antiderivative of 3x squared is x cubed, then the general antiderivative is x cubed plus c. Karena kita tahu bahwa antiturunan dari 3x kuadrat adalah x pangkat 3, maka bentuk umumnya adalah x pangkat 3 plus c. Then we put the condition in, yeah, we substitute x equal to 1 to get the specific value of c. In this case, we get that the value of c is actually -2. Nah, jadi kita tinggal substitusikan x sama dengan 1 ke f capital X. Ya. Kemudian kita dapatkan nilai c-nya adalah -2. Then finally, we have that the antiderivative that solve this problem, yeah, is actually x cubed minus 2. Any question? Is it clear?
Sir, can you repeat again?
Which part?
From the apa ini antiderivative dari f kecil ke f gedenya.
You want me to repeat it in bahasa Indonesia or in English?
In bahasa maybe, sir.
Oke, ya. Di sini kita mencari antiturunan dari 3x kuadrat yang memenuhi f1 adalah -1, ya. Maka antiturunannya dari 3x kuadrat adalah x pangkat 3. Karena x pangkat 3 kalau diturunkan adalah 3x kuadrat. Betul?
Yes, sir. Betul.
Sehingga bentuk umum dari antiturunannya adalah x pangkat 3 plus c. Sampai sini sudah bisa dipahami?
Oke.
Ya, ini ya. So, in general, the antiderivative form is you will always have an additional constant, ya. Jadi kalian selalu punya tambahan konstanta di situ. Nah, then how should we find the value of c? Ya, bagaimana kita mencari nilai dari c? Mencari nilai dari c kita gunakan dengan mensubstitusikan ini, ya. Karena harus memenuhi kapital F dari 1 adalah -1. Maka kita substitusikan, ya, kapital F1 adalah 1 pangkat 3 tambah c, yaitu 1 tambah c. Karena 1 tambah c harus sama dengan -1, maka c-nya adalah -2. Maka bentuk antiturunannya yang memenuhi aturan F1 sama dengan -1 adalah x pangkat 3 -2. Ya. Is it clear now?
Okay, sir. It's clear. Thank you.
Any other question?
I think also.
No?
No, for this one is no.
So, and this is the table for antiderivative formula, ya. Jadi ini tabel untuk antiturunan. And you will use it later. I'm sure in chemical engineering you will use it a lot. Jadi ini adalah tabel dari antiturunan yang kalian bisa pakai nanti, ya. Baik itu di quiz maupun di UTS maupun di UAS. So, if we have x power n, the general antiderivative is 1 over n plus 1 times x power plus 1 plus c, and so on. So, if we want to find the general antiderivative of x power 5, then here we have x power n, yeah, x power n, then the antiderivative is 1 over n plus 1, yeah, so 1 over 6 times x power n plus 1, yeah, times x power 6 plus constant c. And so on, yeah. You can see everything here, yeah. For example, okay, D, we want to find the antiderivative of 2 sine x plus c. You find sine kx, the antiderivative is -1 over k, cosine kx. So we have that the antiderivative is of cosine x over 2 is, cosine. So cosine. So k is 1 over 2 in this case, yeah. So we have that 1 over k is 2 times sine x over 2 plus c, and so on. Any question for this example?
I think it's still clear, sir.
You have to pay attention that the antiderivative of 1 over x is ln x. Yeah. And we have the linearity rules, which we can apply. Yeah. You can read this by yourself. And if we have like this, then the antiderivative, basically, we can split the first part and the second part. And then we find the antiderivative of each part, and then we return them because of this sum or difference rule, and also constant multiple rule and negative rule. We put everything here. And this is a more practical example. Yeah, a hot air balloon ascending at the rate of 12 feet per second now is at height 80 feet above the ground when a package is dropped. How long does it take the package to reach the ground? Jadi di sini ada balon udara yang naik ke atas dengan laju 12 kaki per detik. Nah, pada ketinggian 80 kaki, kita menjatuhkan sebuah paket. Pertanyaannya adalah seberapa lama paketnya sampai ke tanah. Then in this case, we let v denote the velocity of the package at time t. Ya, v adalah kecepatan dari paketnya. And let st denote its height above the ground. Jadi s adalah posisi. The acceleration of gravity near the surface of the Earth is known to be 32 feet per second squared. Ya. Jadi karena di sini pakai satuannya kaki, ya, kita punya percepatan gravitasinya adalah 32 kaki per detik kuadrat. Assuming that we have no other forces act on the drop package, ya. Jadi misalkan kita tidak ada gaya lain, misalkan for example air resistance or drag force or everything else, ya. So we are assuming ideal condition. We know that dv dt is minus 32. Ya. Di sini karena tidak ada gaya lain, maka kita tahu bahwa percepatannya, ya, dv dt adalah minus 33/2. Karena apa? Karena why? Because v is going upwards while the acceleration of gravity is going downwards. So the sign is negative. Ya. Jadi karena v-nya itu kita asumsikan ke atas, karena v-nya di sini adalah hubungannya dengan balon udara yang naik ke atas, maka kita pakai negatif. Then we have that dv dt is equal to minus 32 with v0 equal to 12. Karena why? Because at the beginning, the hot air balloon is ascending at the rate of 12 feet per second. So when the package drop, the speed is actually 12. Then we solve it by finding the general antiderivative of dv dt, which is minus 32 t plus c. Yeah. Then solve c for the initial condition. Jadi kita cari antiturunannya. Maka antiturunannya adalah vt adalah minus 32 t plus c. Kemudian kita cari c yang menyelesaikan yang memenuhi kondisi awalnya. And in this case, we have that velocity is actually minus 32t plus 12. Then now we find the velocity. Next is what we want is to find the position. Why? Because we want to find the time where the package reach the ground. Ya. Jadi kita mau mencari waktu di mana paketnya mencapai permukaan tanah. Then in this case we find that we find another problem. Ya, dsdt equals to v. Jadi dsdt adalah kecepatan, ya, v, with the initial condition s0 at 80. Ya. Posisi awalnya, posisi pada waktu 0 adalah 80. Then we solve it again. We find that this is not Vt. This is not Vt but St. S. So S of t is minus 16t squared plus 12t plus c. Now we solve again c for the initial condition. Then we have that c is equal to 80. So the package height above the ground at time t is st equals minus 16t squared plus 12t plus 80. So finally, we just need to find t positive that satisfies st equal to 0, and we get that t is actually 2.64. Yeah. Now let's go to integrals, which is indefinite integral. Yeah. The collection of all antiderivative of f is actually called indefinite integral. So basically this guy is actually indefinite integral. And in this case, symbol this guy is the integral sign, and the function f is called the integrand, and x is the variable of integration. So for example, we want to evaluate integral of x squared minus 2x plus 5 with respect to x. In this case, we have that the integral is x power 3 over 3 minus x squared plus 5x plus c. Don't forget to add plus c in the end. So now we are asked to find an antiderivative for each function mentally, and check the answers by differentiation. Okay. For a, basically the antiderivative is x squared. Why? Because d dx of x squared is 2x, and for b is x cubed over x cubed over 3. Why? Because d dx of x cubed over 3 is x squared. And for c, the antiderivative is x cubed over 3 minus x squared plus x. Why? Because d dx of x cubed over 3 minus x squared plus x equals to x squared minus 2x plus 1. Is it clear for this one? So in this case, we don't need to add the constant because we are not asked to find the general antiderivative ya. Kita tidak perlu menambahkan konstan karena kita tidak diminta untuk mencari bentuk umum dari antiderivatifnya, antiturunannya. Now the second one, yeah. Find antiderivative of this function mentally. In this case, we have that the antiderivative, let's say capital Fx, is 2x plus 5 over 3x squared. Why? Because f prime is actually 2 minus 5 over 3 times, plus 5 over 3 times minus 3 over x cubed. So this is equal to 2 minus 5 over, oh, sorry. This is not correct. So this should be 5 over x. Yeah. Why? Because the derivative is 5 times, okay, 2 plus 5 times minus 1 over 2x squared. Sorry, 1 over x squared without 2. So in this case, we have that the derivative is 2 minus 5 over x squared. And for this one, we have that f of x, capital F of x, is actually minus cosine pi x over pi minus plus cosine 3x. Why? Because if we find the derivative, it is actually sine px times p minus plus over p over pi and minus 3 sine 3x. Yeah, if we eliminate the pi, then we have the same thing up there. So that's it. And ya.
Itu nggak ditambah C lagi?
No. Okay. As I said before, in this case we are not asked to find the most general antiderivative form. Di sini kita tidak diminta untuk mencari bentuk umum dari antiturunannya. That's why we don't need to add C.
Berarti kalau misalnya we find this question, so we answer like that short.
Yes, that's correct.
Okay. Biasanya
you can add C, ya. Anda bisa menambahkan konstanta C. That is better. But the same answer as what I have here is enough. Jadi kalian boleh menambahkan konstanta, lebih baik. Tapi kalau menjawab seperti yang saya jawab juga cukup ya. As long as you are not asked to find the most general antiderivative. Selama Anda tidak diminta untuk mencari bentuk umum dari antiturunannya. Ya. But in this case, ya, in this new question, we are asked to find the most general antiderivative. Ya. Di sini kita diminta untuk mencari bentuk umumnya. Then, in this case, we have that integral of 8y minus 2 over y power 1 over 4 dy is actually equal to an integral of 8y minus 2 power minus 1 over 2 times y power minus 1 over 4 dy, which is equal to 4y squared plus, minus 8 over 3 y power 3 over 4 plus c. Yeah. Why? Because if we differentiate it, the dy of 4y squared minus 8 over 3 y power 3 over 4 plus c, we have that the result is 8y minus 2y power minus 1 over 4 is equal to 8y minus 2 over y power 1 over 4. Now see that in this case we are asked to find the most general antiderivative. Yeah? That's why we have to add C in this case. Ya, di sini karena kita diminta untuk mencari bentuk paling umum dari antiturunannya, maka kita harus menambahkan C. Ya. Any question?
Sir, so the C is become 2 per y 1 and 1 to the power 1 per 4.
No. This is the answer. This is your answer. This is just to check.
Okay.
Yeah.
Okay, sir.
So this should be easy. This should be easy. Now this one. Solve the initial value problem. So in this case, what we want to find is y is equal to integral of 2x minus 7 with respect to x, which is equal to x squared minus 7x plus c, and then we solve we find the C by solving this. Y2, which is equal to 2 squared minus 7 times 2, plus C, which is equal to 4 minus 14, so minus 10, plus C must be equal to 0. In this case, we have that C equal to 10. So the solution is Y equals to x squared minus 7x plus 10. Yeah. Any question?
Oh iya sir, kalau yang equal to zero-nya itu nanti dikemanain atau nggak dipakai aja?
What do you mean?
Itu kan minus 10 plus C is equal to 0, berarti zero-nya tuh nggak dipakai nanti ya sir?
No, we only need this information ya. Jadi kita cuma butuh Y2 sama dengan 0 ya untuk mencari nilai C. Bukan nggak dipakai sama dengan nolnya. Ini dipakai. Karena Y2 sama dengan 0, maka kita bisa dapat C-nya berapa.
Oh, oke.
Ya, any other question? No?
No sir.
Then the last challenge. Suppose that the velocity of a body moving along the s-axis is st equal to v equal to 9.8 t minus 3. So find the body's displacement over the time interval from t1 to t3. Given that s equal to 5 when t equal to 0. So to answer the first question, we need to find s, which is integral of v dt, which is equal to integral of 9.8 t minus 3 with respect to t, which is 4.9 t squared minus 3t plus constant c. So we have that s equal to 5 when t equals to 0. So in this case, we have that s0, which is 4.9 times 0 squared minus 3 times 0 plus c is equal to 5. So in this case, we have that c is equal to 5. Then we have that s of t is actually 4.9 t squared minus 3t plus 5. So the displacement, so in this case we have that s of 1 is 4.9 minus 3 plus 5. So 5 minus 3 is 2, so we have that 6.9, and s of 3 is 4.9 times 9 minus 3 times 3 times 3 plus 5, which is equal to 9 times 4.9 minus 1 plus 5, which is equal to 9 times 3.9 plus 5, which is equal to, okay, let me use the calculator. 3.9 multiplied by 9 plus 5. Yeah. So this is 40.1. Then in this case, the displacement from t equal to 1 to t equal to 3 is S3 minus S1, which is 40 minus 1 minus 40.1 minus 6.9, which is 33.2 units. Any question? Is it clear?
Yes, sir.
So for the second and the third one, the second one is the same basically, yeah. You just need to find s equal to minus 2 when t equal to 0, and then finish it like what I did. And then the number 3, you just change s equal to s0 when t equal to 0, and that's it. That's it for the antiderivatives. Now I want to introduce to you sigma notation and Riemann sum. Why we need this? Because in the afternoon session I will deliver the materials about definite integral and fundamental theorem of calculus and indefinite integrals. Sigma notation, yeah. This is only introduction, yeah. What is a sigma notation? Sigma notation is notation like this, yeah. Sigma notation allow us to write a sum with many terms in the compact form, ya. Jadi dengan notasi sigma kita bisa menulis jumlah dari beberapa banyak suku gitu ya, dengan bentuk yang lebih compact, lebih padat, gitu, lebih mampat. So the notation looks like this, yeah. So basically, if we have sum of k equals to 1 to n of ak is basically a1 plus a2 plus a3 plus up to plus an. Jadi kalau kita punya jumlah ya, sigma dari k sama dengan 1 sampai n dari ak ya, berarti kan indeksnya ak ya, k-nya adalah dari 1 sampai n. Maka ini adalah a1 tambah a2 tambah a3 sampai an. So in this case, we have that the summation, the sigma is basically the summation symbol, ya. Notasi penjumlahannya adalah sigma, and then k is the index, which in this case starts from 1 and end at n. Jadi penjelasannya seperti ini. Any question? No?
I think no, sir.
So basically, we can write 1 squared plus 2 squared plus 3 squared plus 4 squared up to plus 11 squared as sum of k from 1 to 11 of k squared. Or f1 plus f2 up to plus f1000 is sum of I equals to 1 up to 1000 of fi. Yeah. This is the example. Any question? Is it clear?
Clear, sir.
Yeah. But okay, you have these rules that you can use, yeah. Sum rule, difference rule, constant multiple rules, and constant value rule. You save it for later, yeah. Well, basically in this part of integral, we are not really using these rules, but just so you know that this rule exists. Yeah. What I want to talk about is the Riemann sum. What is the Riemann sum? Ya. Apa itu penjumlahan Riemann? Riemann ini nama seorang matematikawan. Ya. Riemann is a mathematician that found this integral method. Ya. Jadi dia menemukan ini, penghitungan integral. So basically, what is integral? Integral is basically the area of the area below the curve, so the area between the curve and the x-axis. Ya. Jadi integral terbatas itu pada dasarnya adalah luas dari area di antara fungsinya dan sumbu x. We can approximate, ya. We can imagine that if we want to, let's say, if we want to measure the area of Java Island. Misalkan kita mau mengukur luas dari Pulau Jawa. And in this case, we can imagine that the top area, the north area, the north parameter as a function, and the south parameter as another function. Jadi kita misalkan yang bagian utaranya suatu fungsi tertentu, yang pantai selatannya fungsi tertentu juga. Then how to compute the area, how to measure the area, basically we can use the integral. Jadi untuk mencari luas Pulau Jawa, misalkan contohnya, kita bisa menggunakan integral, ya, from the leftmost, from the eastmost from the westmost part of Java Island up to the eastmost part of Java Island. Ya. Jadi kita hitung integralnya dari sisi paling timur, sisi paling barat Pulau Jawa sampai sisi paling timur Pulau Jawa. But in practice, it is really hard to find the function. Ya. Jadi pada prakteknya susah sekali bagi kita untuk mencari fungsinya itu seperti apa. Riemann introduce this method, ya. Pak Riemann ini mengenalkan metode ini, ya. How we split the area into many rectangles, ya. Kita bagi areanya menjadi banyak persegi panjang. Then if we compute the area of one rectangle, it is much easier, right? Untuk menghitung luas dari satu persegi panjang itu jauh lebih gampang kan, ya, daripada menghitung integral. Agree?
Agree, sir.
Yeah. Then that's why we do this. Yeah. This is basically Riemann sum, and we can write this in an equation that looks like this. Yeah. This is the Riemann sum. The Riemann sum is basically the sum of k from 1 to n. Yeah. K from 1 to n of f of ck, ya, dari nilai fungsi pada titik c ke indeks k multiplied by the length, the interval, ya, dikalikan dengan panjang intervalnya, ya, misalkan di C1 panjang intervalnya x1 minus x0, di C2 panjang intervalnya adalah x2 min x1 dan seterusnya, ya. Any question for this? Okay, if
I
not,
think not yet, sir.
then we can actually choose the intervals to be equal. Let's say delta x1 equal to delta x2 up to equal to delta xn, which is b the rightmost minus the leftmost over n, ya, over how many partition that we want to make, ya. Misalkan di sini kita membuat intervalnya sama, ya, jadi deltanya sama. Cara menghitungnya adalah titik paling kanan dikurang titik paling kiri dibagi dengan banyaknya partisi yang mau kita buat. Ya. So in this case we have this Riemann Sum Formula. Kita punya bentuk formula seperti ini. Ya. And you will use this Riemann Sum Formula a lot when you study about numerical methods. Later maybe in your second or third year, I think. I don't know. But you will use this a lot. So basically, this is the idea, yeah. And we have that P is the norm of partition. The norm of partition is the longest interval. But if we have this equal interval, then delta x is the norm of the partition. And the idea is that, okay, the definite integral that we know is basically the limit infinity of this Riemann sum. Jadi pada dasarnya mudah-mudahan di buku SMA masih ada ya, karena di buku SMA saya dulu masih ada. Pada dasarnya integral yang ada batasnya dari batas bawah sampai batas atas itu adalah penjumlahan Riemann yang kita ambil limitnya, limit partisinya menuju tak hingga. So basically the partition, we want to make the partition as small as possible so that the error is minimized ya. Jadi kita mau membuat partisinya sekecil mungkin ya. Jadi deltanya sekecil mungkin, partisinya sebanyak mungkin. Supaya ini kalau di sini kan kalau kita menghitung jumlahnya pasti ada selisih ya. Ada selisih dari misalkan ini area yang di bawah ini. Ya, area yang saya kasih kotak ini kan ada selisih antara fungsi dengan kotaknya ya, dengan persegi panjangnya. Selisih ini menimbulkan error ya yang kita minimalisasi dengan mengambil limit menuju tak hingga sehingga kita mendapat mendapat definite integral ya, integral definite yang ada batasnya. That's it, the material for this morning ya. Any question before I end this morning session?
I think no.
Berarti nanti siang lanjut ini Riemann sum ya, Sir? Definite integral ini ya?
In the afternoon session, we will continue with definite integral.
Oke, Sir.
Ya.
Okay.
If there is no question, let me end this morning session. See you this afternoon. Assalamualaikum warahmatullahi wabarakatuh. Good morning.
Waalaikumsalam. See you in the afternoon, sir.
Thank you, sir.
Thank you so much, Sir.